So, why do we use such a very weird, very convoluted way of thinking about creating a process? One reason that I already mentioned was basically that, well, it's actually more elegant, which you will come to realize later. It's actually simpler for the operating system, has less parameters, but also it has lots of other pluses. If you are looking at something like a Unix shell, which is basically what you use when you go to terminal in Linux or Mac OS, OS X basically, or even PowerShell. I mean, well, PowerShell is Windows, so but still a lot of the Windows idea of the Linux ideas. But in reality, fork and exec are essential to building a Unix shell basically. It lets the shell run code after the call to fork, but before the call to exec, basically. And you will build a shell soon, and that will be fun, I promise. So, but the computer is in general much more than just the CPU. So you have the mouse, the keyboard, the monitor, blah blah blah, and each device has a different size of data for I/O, and that basically means if you're trying to access one of these devices, you might come up and say, okay, I should basically have a syscall that is read from keyboard, a syscall that is print to monitor, and a syscall that is like, yeah, print to network card or send to network card, and so on and so forth. So you will either have a syscall per device that exists on Earth, and basically if you have different, like, let me show you an example. This is a very nice Swedish keyboard which has a very weird layout with the AÖE letters which do not exist in most other languages, while my other keyboard uh, on my laptop is a completely different keyboard. And then there's even the more Microsoft looking nice looking fancy keyboard. So now we have just seen three different keyboards. Each of them has a different set of keys. So the Swedish keyboards have different letters. The Microsoft keyboard has controls for sound. The MacBook keyboard does not have a page up and page down. So you end up with all of these things. So you're not going to, it will not scale to have a syscall per device, because you do not know if the keyboard is Chinese, then it's completely different set of letters than if it's English. So the way that Linux revolutionized the way that all of this input output is done, because in essence, basically sending data to your monitor is actually output, and reading data from your keyboard or your mouse is input. Linux basically thinks of everything as a file, and you have, for a file, you need to open it, to close it, to read from it, and to write to it. And if you think about it, so if you are going to access your keyboard, you open the keyboard just like a file, you close the keyboard just like a file, you read from the keyboard, and you write to the keyboard. So you deal with the keyboard as a file. Does that even make sense? Yes, it does, because in reality, when you open the keyboard file, you're actually making a connection to the input of the keyboard, and you can read from it. You cannot write to a keyboard because, well, you cannot really print things on keyboard. You can type things on a keyboard, and these things that you type on the keyboard are tunneled to a file, if I may say. They are stored in a file that then can be read by the operating system. Okay? The operating system is not going to basically give commands to the keyboard to do anything. If you're talking about the display, okay, then if you're talking about a monitor or one of these devices, then you basically open the device file, you open the monitor file, and then when the operating system wants to have something that is presented to you in the display, it writes data to that file, which can be then read from the display and presented to you. Okay, so now the operating system all of a sudden doesn't need to think about anything regarding the devices. It needs basically to provide this interface of file, and the device drivers / the devices need to read and write from these files as such. Okay, now very simple definition, and it's very modular. You can extend it to any device that you have, and any input output device that you have. So as I said, open acts now as your Swiss knife. You open a file, you open, if the file does not exist, you can return an error. If the file does not exist, you can create the file and open it. If the file does exist, you can return an error. If the file does exist, you can open the file. Okay, what am I talking about now? So if the file does not exist, you can return an error. So suppose now that Linux is trying to write, the operating system is basically trying to write to a monitor that I do not have connected to my computer. I had it connected and I unplugged it. So now when you try to project on that, you should get an error. You cannot basically present things on a monitor that does not exist anymore. Okay, maybe if the file does not exist, you create the file and open it. So let us give an example. With the actual file system, you're basically writing to the storage device, you're writing to your disk. So if the file does not exist, you want to create the file and open it. It might be the case that if the file does exist, you want to return an error. So if you unplugged, for example, if you unplugged any USB stick, okay, and you find that the file system that you mounted, whatever you see, the drive for the USB stick is still there, then you should give an error. You should return an error and then remove it from the user view, and so on.